Good day, students. We will start with unit number 3. I want everyone to take down your notebook and make a note of this video lecture. This lecture, whatever is there in the video, will not be repeated in the classroom sessions. Okay. So please take down. The title of unit number 3 is DC Transients. Right. These are the contents which we are going to see in unit number 3. Like you just have a go through of this contents. So before starting with the content, you should understand what do we mean by transients. Okay. So transients, say for example, you are having a circuit with input and output. Let us understand the circuit is having some storage component like inductance and capacitance. Okay. You already know that inductance will store energy in magnetic field and capacitance will store energy in the electric field. So like say for example, you are giving the input something like this. At a time t is equal to 0, it is jumping from 0 to 5 volts. There is a sudden change from 0 to 5 volts at when the input. So you are expecting the response or the output of the circuit to have the similar changes at a time t is equal to 0. So this is the time axis. Till 0, you want a sudden changes, it should go suddenly to 5 volts, but this will not happen if you are having this will happen if you are not having any storage element inside the circuit. Okay, but if you are having, so this is without storage element, whereas if you are having a storage element like inductance and capacitance, you cannot expect the sudden change at the instant change. So it will take some time to reach. Okay, so there is some delay time. So to reach the maximum value, it will take some time. So it may be taking in this way, or it may be having something like this. It may, see for example, this is the actual required response, but you may be getting a response something like this. So like so this is what so in this response or the output, you can see two areas. So this shaded area, what I am shading, is the place where the output is changing with respect to time. If you are having only DC source as the input, you should not have any change in the, you should not have the output changing with respect to time. But because of the presence of the storage element like inductance and capacitance, you can see the output is changing for some particular time. Then only it is reaching the constant. Then only it is taking the constant value. Similarly, here also you can see the output is changing, and after certain time it settles down to the constant. So this area, shaded area in both these output response, is called the transients. And the output where it is having constant value is called the steady state. So what you need to understand is, if inductance and capacitance are involved in a circuit with a DC source, then you cannot expect the output to be a purely steady state instantaneously. This is because you take the equation for inductance, capacitance, current equation for capacitance is given by IC is equal to C into dVc by dt. That is voltage across the capacitance. Differentiating that and multiply by the capacitance value will give you the current. Therefore, you please understand, you cannot expect the current voltage across the capacitance to change instantaneously. Similarly, current through the inductance cannot change instantaneously, because if you take the voltage across the capacitance, VL is equals to L into DIL divided by dt. It means that the current through the inductance will not change instantaneously, and the voltage across the capacitance will not change instantaneously. So this is the reason why you are having a output which is changing with respect to time, even though the DC source is present. But after certain time, what will happen? It will obviously go into the steady state. So in this unit, what you are going to understand is, on applying the DC source to the inductance circuit which is consisting of inductance, or circuit which is consisting of capacitance, you will find the response is having totally two things, two area. One area is transient, another area is steady state. Okay. So this is very important. You please make a note of it. Number one is transient, another one is steady state, right? Now, you need to understand, you are going to analyze the steady state response. That is, you are going to only check at this point how the circuit behaves, okay, and how to analyze the given circuit at this point. I am not talking about transient now. I am talking only about the steady state. Okay, so these are the steps you have to understand. So the steps in determining the steady state response or the forced response for the RLC circuit with DC sources are: first step is you have to replace capacitance with open circuit. Second step is if you are having an inductance, you replace the inductance with short circuit and then solve the remaining circuit. Say this is because, please understand, I told you inductance will store energy in magnetic field. Therefore, when inductance are coming into picture, you need to be, you are always working with the current through the inductance. I already told you current through the inductance will not change instantaneously. So, if the current is constant, then what will happen to the inductance? Voltage across the inductance is 0. Therefore, at a steady state, the current through the inductance is constant. Okay, the current through inductance is constant. Therefore, the voltage is 0. Voltage across the inductance is 0. Therefore, short circuit. The same thing for the capacitance. When you are taking the capacitance, you know capacitance will store energy in electric field. Therefore, what will happen? Electric field, in the sense you have to consider only with respect to the voltage. If the voltage is constant, across the capacitance is constant, then what will happen? Current through the capacitance will become 0. Therefore, if the current is 0, then what will happen? The capacitance will act as a open circuit. Okay. So that is what the steps are defining you. So to understand the analyze the steady state response, if you are having a DC source with inductance and capacitance, first step is you replace all the capacitance with open circuit. Second step is you replace all the inductance with short circuit. Third step is you solve the remaining circuit. So take this example. In this example, this is a DC source. There is connected through a switch, involves R, L and C. All these things are there. So at a time t equal to 0, what is happening? The switch is trying to close. Okay. So the switch is trying to close. It means that what earlier, before time t is lesser than 0, there is no connection between the DC source to this entire part of the circuit. Once the switch is closing, what will happen? There is a sudden input happening to this particular circuit. It means that sudden change in the for the circuit. Okay. Whereas so what will happen? Once the sudden change is happening, you cannot expect an immediate change with the L and C, because L is also a storage element, C is also a storage element. But what we are going to study now is only steady state response. We are not studying the transient response now. First, initially you understand the steady state, then we will go for transient response. Okay. Therefore, once the voltage is applied, immediately you will not find change. After a certain time, everything will be constant. Okay. So during that constant, current through the inductance will be constant. Therefore, voltage across the inductance becomes 0. Inductance will become short circuit. Similarly, voltage across the capacitance is constant. So current through the capacitance will be 0. Therefore, capacitance will act as an open circuit. So you have to redraw the circuit. The circuit under the steady state will be something like this. Inductance place is short circuit. This is the capacitance place, which is open circuit. This is the resistance. So you are having only two resistance. One is with 5 ohms. Another one is also with 5 ohms. Whereas inductance is short circuited, capacitance is open circuited. So for analyzing, you have only resistive circuit. So you want to find out the value for Ix and Vx. Ix is the current through the inductance. Vx is the voltage across the inductance. So as per this circuit, current through the inductance is also current through the R1, this 5 ohm resistance, and the voltage across the capacitance is also voltage across this R2 for this 5 ohm resistance. Okay, so you can solve it. You know very well, 1 ampere current, this becomes a series circuit, so 1 ampere current will flow. So Ix will be equal to 1 ampere and Vx will be equal to 5 volts. Okay. Take this example, the same thing, at a time t is equal to 0, the circuit switch is closed, therefore there is a sudden change in the input. When sudden change in the input is happening, the circuit, the sudden change in the output will not happen. We will understand the transient response later. You draw the circuit for steady state response. So in steady state response, you should make the inductance is short circuit and capacitance is open circuit. So in this case, you will have a network is simplified like this. Okay, 5 ohm, 10 ohm and 10 ohm. Your network is simplified like this. Question is, what is I1 value, I2 value, I3 value? I1 is the current flowing through 5 ohm resistance. I2 is the current which is flowing through this 10 ohm resistance. Now, sorry, I3 is the current flowing through this 10 ohm resistance. I2 is the current flowing through this 10 ohm resistance. Okay. Therefore, if you try to solve this, you will get I1 is equal to 2 ampere and I2 is equal to 1 ampere. Okay. Take this example, again the same thing. At the steady state, what will happen? Initially, you can see, initially the switch is closed. Therefore, all the current will flow only through this short circuit network. So, initially the switch is closed. At a time t is equal to 0, switch is opening. So, at a time t equal to 0, what will happen? This entire circuit will have a input as 2 ampere source. Okay. So, under steady state, you will draw capacitance is open circuit, inductance is short circuit. So, under steady state, you draw the network. So, your network is very simple. It's only a single, one single loop. Question is to find out the current flowing through IA. Current flowing through 24 ohm resistance. So, you can easily answer current flowing through 25 ohm resistance is only 2 ampere network. Okay. So, this is our some example, simple example. So, what you need to understand is at the steady state means that not at the exact instantaneous changes with respect to input. Just after some time at the steady state, we will say at a time t tends to 0 infinity. 0 infinity in the sense t times to at a time t is equal to 0, you are changing the input. So at a time t tends to infinity. It's not exactly infinity, 0 infinity. We call it as 0 infinity, means that extension of the maximum extension of the 0. During that time, what will happen? The circuit will become the steady state circuit. So under steady state, because only DC source is applied, you need to understand the inductance will be short circuited and capacitance will be open circuited. You can directly analyze the given circuit. Okay. Now, we will understand what is the transient response. Okay. So, transient response, I told you earlier, transient response is nothing but the response or the output which is changing with respect to time. Right. So, so we are going to see this transient response for the two different circuit. One is first order circuit, another one is second order circuit. So, here first order or second order in the sense, if your circuit is involving only one storage element, it can be only either capacitance or it can be only either inductance. In that case, the circuit, you try to write the differential equation, you try to write the Kirchhoff's law equation for the given circuit, you will find a differential equation of order 1. Therefore, the circuit is called as a first order circuit. Whereas, if you are having two inductance which cannot be simplified. Okay, simplification in the sense, two inductance is not in parallel, two inductance is not in series. Or if you are having two capacitance which cannot be simplified. Similarly, it is neither in series nor in parallel. Or if you are having an inductance with capacitance, one inductance with one capacitance. These combination will give you second order circuit. In the sense, if you try to write the basic Kirchhoff's current law or basic Kirchhoff's voltage law for this respective circuit, you will find that the order of the differential equation is the square times. Okay, so that is the difference between first order circuit and the second order circuit. So like earlier in unit number 1 and unit number 2, you have studied DC circuit only, but only with resistance. If DC involves only the resistive component, then you will get an algebraic equation. Algebraic equation in the sense there is no differentiation or integration. But the same DC source with inductance and capacitance, you will be getting a differential equation. Okay. So let us understand how the differential equation is formed. And always, just 1 minute. Okay, so here I want to tell you one important thing. First, when you are having capacitive network, what you need to understand is capacitance will store energy in electric field. It means that you always are interested to find what is the voltage across the capacitance. Okay. Number 2 is inductance will store energy in magnetic field. It means that you should be interested only in finding the current through the inductance. So if R and C is given to you, you please find only the voltage across the capacitance as your first step. Otherwise, if R, L and L combination is given to you, you please try to find only the current through the inductance as your first step. The rest, whatever the question is, whatever may be the response, first step is you find what is the voltage across the capacitance and current through the inductance. Rest all you can find from that respective point. Okay. So first I will tell you how to write the differential equation. Then I will tell you what is the generalized solution. You can directly solve all the problems with this generalized solution itself. But also you should know how to write the differential equation for the given network. Okay. So let us consider an RC circuit without sources. One R and one C forming a series circuit. It's without source. There is no external source given. So what you have to do is, we are interested only in finding out what is the voltage across the capacitance. Always, if RC is given. So under this case, what you do is apply Kirchhoff's voltage law. Apply Kirchhoff's current law. Apply Kirchhoff's current law. Okay. At this node A. So if you apply Kirchhoff's current law at this node A, you can write current through the resistance as Vc divided by R. Voltage across the capacitance, voltage across the resistance are same. So Vc divided by R. And the current through the capacitance is given by C into dVc divided by dt equal to 0. You organize this equation. So dVc divided by dt plus Vc divided by Rc equal to 0. So what I made is this order of the different, you can see this is the differential equation for this given circuit. Order of the differential equation is 1. So only this is called as in first order circuit. Okay. And also the coefficient of the highest degree, you please make it as 1 always, so that it is easy for us to solve the equation. Okay. Similarly, when you are having an RL circuit without source, you are having only resistance and inductance. Okay, so this is in series combination RL circuit. If you are having RL circuit, what you need to understand is it will store energy in magnetic field. Therefore, we are interested finding only the current through the inductance. Therefore, here you write KVL, Kirchhoff's voltage law. So Kirchhoff's voltage law, you have to find out what is the voltage across this resistance, what is the voltage across this inductance. So voltage across this resistance is nothing but current through the inductance IL into R. Voltage across this inductance is nothing but L into DIL divided by dt equal to 0. So organize this equation. So organizing this equation in the sense, always please understand, you have to make the highest degree coefficient as 1. Okay, which is very important. So you will get an equation like this. So you can see this is the first order. Order of the degree of the highest degree of this is 1. So this is called as in first order differential equation. So please always understand Whenever RC is given, you are interested in finding out the voltage across the capacitance. RL is given, you are interested in finding out the current through the inductance. For RC combination, you write KCL. For RL combination, you write KVL. Okay. If you follow this, you will easily find out the differential equation. Okay. Now, steps for solving the first order differential equation. You go through this differential equation carefully. First step is apply Kirchhoff's current law at the node of the capacitance if the circuit is RC. That is what we have done earlier. Okay. And the second or apply Kirchhoff's voltage law to the loop of the inductors if the circuit is RL. Okay. So this first step is what we have done in this. Second step is organize the equation. Organize the equation in the sense you have to write the degree of equation in the descending order and also ensure that coefficient of the highest degree is 1. Okay. So that is the organizing the differential equation. Third step is assume a solution of the form k1 plus k2 e power st. This is always constant because you are studying only first order circuit. So you will have only steady state response plus transient response. So always your input thing will be like this. This is the form you will get always. Okay. Then substitute the solution. You are assuming this is the solution. Substitute the solution into the differential equation. You have already got the differential equation. You need to substitute in the differential equation to determine the values of K1 and S. You need to find out what is the value for K1, what is the value for S. Otherwise, what you can do is, you can only write. So, see, please understand. So, your solution will take this form. What does this mean? This means this is the portion which is changing with respect to time, or we call it as a transient. Okay. Whereas this is the portion which is constant, it's a steady state. Okay. So this is a transient response plus steady state response. You will get two responses. So, so what you can do is you can also solve, we can determine K1 by solving the circuit in steady state, which we have done in the previous slides. Okay. What we have done, you know, in steady state, what is the procedure? Capacitance is open circuit, inductance is short circuit. Solve what is the voltage across the capacitance, what is the current through the inductance. That will give you the value for K1. Okay. And after finding the value for K1 and S, you substitute in this equation and you have to find the value for K2 by understanding the initial condition. What is initial condition? Initial condition is always what is the current through the inductance at some given time, or what is the voltage across the capacitance at the given time. So write the final solution. So these are the steps which we are going to follow for the first order circuit. So now let us start with an example. Say first let us understand what is RL circuit and RC circuit with sources. So now we are having a source, called the source name is Vs. You are having R and L. Now I told you when RL circuit is given, you are interested in finding out the current through the inductance. So you are going to write only KVL, not KCL. So write KVL for this. If you write KVL for this, minus Vs plus IL times of R plus L into DIL by dt equal to 0. Organize this equation. As I told you, you need to you should have the order of the degree. 1 should be equal to 1. Coefficient should be equal to 1, equal to Vs divided by L. So this is the equation. Okay, this is the equation. Now you need to solve this equation. You are going to follow the previous step. So what is the previous step? You are assuming the solution. Okay. So here I will teach you to find it. What we will do is we will distribute this into see, this is this area becomes because of the voltage is applied. Say for example, if voltage Vs is equal to 0, it means that 0 is the input. 0 is the input. If you are able to get some output, it is called as a natural response. Okay, with voltage is 0, you are getting the output. This is called as a natural response. With voltage is not equal to 0, you are calling it as a forced response or steady state response. So what I will do now is, so we will see about RC later. what I will do now is, we are assuming a solution k1 e power st. Let us consider for the natural response. The natural response is nothing but input is equal to 0. So dIL divided by dt plus R by L into IL equal to 0. This is a natural response. Now for this natural response, this is the solution k1 e power st. Now what you need to do is, you have to write IL is equal to k1 e power st. Substitute IL is equal to k1 e power st in this equation. Okay. So if you substitute that, you will get k1 s e power st plus R by L k1 e power st equal to 0, which is nothing but k1 e power st into s plus R by L equal to 0. From this, you know, k1 e power st cannot be equal to 0. Therefore, s plus R by L is equal to 0. From this, you got the value for s is equal to minus R divided by L. Okay. So, you got the solution for the natural response. In the sense, so I natural response, this is only for natural response. Okay. I natural response is nothing but k1 e power minus R by L into t. Next, you need to know forced response or steady state response. What is forced or steady state response? Inductance will become short circuit under steady state. Okay. So, if inductance becomes short circuit under steady state, what is the current through the inductance? It's nothing but Vs divided by R. So, current through the inductance or forced response. Forced response is nothing but Vs divided by R. So, the total response IL of t, which is nothing but natural response plus the forced response. So, this becomes k1 e power minus R by Lt plus of Vs divided by R. Now, this is the total response what you are having. Here, the only unknown thing is the constant k1. So, you need to find out the value for the constant k1. Okay. So, to find the value for the constant k1, what you can do is, you apply initial condition. So, what is the initial condition? What is the initial current through the inductance? Let us assume the current is 0. If the current is 0 at a time t is equal to 0, you have the equation IL of t equal to k1 e power st plus Vs divided by R. This is from the previous part. We have completed this one. K1 e power e power minus R by Lt into Vs plus Vs divided by R. So, k1 e power s is nothing but minus R by L. So, later we will substitute. This is the form of the equation. So, you apply t is equal to 0, initial condition. So, IL of 0, initial condition is 0, which is equal to k1 plus Vs divided by R. From this, what do you understand? K1 is nothing but minus Vs divided by R. So, put in this equation, you got the answer for the constant k1 also. So, put everything in the total solution. Therefore, you will get IL of t is nothing but Vs divided by R, which is into 1 minus e power minus R by L into t, because S is minus R by L. So, this is the final equation for the series network, which involves only one R and one L. Okay. Here, this R by L is called R by L, or inverse of R by L is called as a time constant. L by R is the time constant, or inverse of R by L is the time constant which involves the inductive network. So, this can be written as IL of t can be written as Vs divided by R into 1 minus e power minus t divided by tau. Now, what you do is, you apply various values of various values for t. Take an example, t is equals to 1 tau, 2 tau, 3 tau, like that. So, okay, so now what you do is, and find the various values of IL of t. So, let us consider t equal to 0, 1 tau, 2 tau, 3 tau, 4 tau, and 5 tau. Okay. So if you consider that, just a minute. So at a time t equal to 0, this equation will become 0 because e power minus t is e power 0 is 1. So 1 minus 1 will give you 0. Therefore, at a time t equal to 0, you get 0. At t equal to 1 tau, you apply t is equal to tau here, e power minus 1. This gives you 0.63 Vs by R. Okay, at 2 tau, you get 0.86 Vs by R. At 3 tau, you get 0.95 Vs by R. Similarly, at 4 and 5 tau, 4 tau and 5 tau, you get 0.98 Vs by R and 0.99 Vs by R. This means that at the time constant t is equals to 5 times of the time constant, you will get the maximum response 0.99 times, which achieves the steady state. Okay, so if you draw this, if you try to draw the graph, you will get a graph like this for time t at 0, tau, 2 tau, 3 tau, 4 tau, 5 tau. At 5 tau, no, see until this it will be like this. Sorry. Okay, so at 5, after 5 tau it will reach the steady state. Okay. So 0 to 5 tau, it is the values will be changing. At 5 tau it is approximately, it gives the maximum value. This is the circuit with the source which involves the RL only. Okay. So you can see from this graph, it's an exponentially increasing. Okay. Whereas if this particular circuit, if you try to solve here, you will get only Vc e power minus t by Rc. This will be the solution. Vc is equal to e power minus t by Rc. It's an decreasing exponentially, in the sense, if there is no source applied to the RC network, then capacitance, whatever the energy stored in the capacitance, will try to dissipate through the resistance. So at a time t tends to infinity, the voltage across the capacitance will become 0. Similarly, for this also the solution, current through the inductance is nothing but e power minus t divided by L by R. L by R or R by T, RT divided by L, anything. Okay. It means that it's also decaying like this. That is, if there is no external source applied, the initial charge which is stored by the inductance will become 0 at the time t tends to infinity. Whereas if the external source is applied, then it is trying to charge and store the energy. Okay, so this is the circuit for the RL. Now next let us see the same combinations for RC network. RC network, say for example, you are having a source with R and C. As I told you earlier, capacitance will store energy in magnetic field or electric field. Therefore, we are interested in finding out the voltage across the capacitance. Always solve only current through the inductance first and voltage across the capacitance first. So, since this circuit is involving capacitance, what you need to do? You are applying the Kirchhoff's voltage law. So, Kirchhoff's voltage law for this node, call this node as A. So, KCL at node A. What is KCL at node A? Vc minus Vs. Current through the resistance is Vc minus Vs divided by R, plus current through the capacitance is C into dVc divided by dt equal to 0. Organize this equation, d times of Vc divided by dt plus of Vc divided by Rc equal to Vs divided by R. So again what you are having? You are having the right side equation also. If Vs equal to 0, then that is natural response. If Vs is not equal to 0, then that is forced response, which is something similar to the previous example what we have seen here. Okay, so you can carefully watch this differential equation, and this differential equation takes the same form. Okay, so finally you will also have, so you are going to solve everything in the same step. You please follow the same step. So okay. So first natural response, we will understand natural response. For natural response, we are assuming the solution is K1 e power st. Substituting the equation, differential equation, dVc divided by dt plus of Vc divided by Rc equal to 0. Substitute Vc is equal to K1 e power st. Therefore, you will get S is equal to minus 1 by Rc. Okay. So, if you substitute and simplify, you will get S is equal to minus 1 divided by Rc. As usual, what we have done for the inductance, same thing you are doing it for the capacitance now. Okay. Now, next is forced response. For finding the forced response, I told you, you write the steady state equation. So, at steady state, in the inductance, capacitance will act as an open circuit. So, if capacitance is acting as an open circuit, the voltage across the capacitance will be nothing but the entire source voltage, because there is no meaning of the resistance now. So whatever is the voltage here will be appearing across this open circuit network. So forced response Vc is equal to Vs. In natural response, Vc is equal to K1 e power st and S is equal to minus 1 by Rc. In forced response, Vc is equal to Vs. Therefore, the total response is Vc of t equal to Vs plus K1 e power minus t divided by Rc. Now you need to find out what is the value for K1. So to find the value for K1, as usual, assume the initial condition Vc of 0 equal to 0. So now you substitute t is equal to 0. Therefore, you will get K1 is equal to minus Vs. The total solution is Vc of t will be equal to Vs into 1 minus e power minus t by Rc. This is the general form. Okay. So here Rc is the time constant. Tau is equal to Rc. So if you are taking inductive network, please understand tau is equal to L divided by R. For capacitive network, tau is equal to Rc. Whereas the form of the equation, everything is one and the same. Okay. So this is the introduction of how to write the differential equation and how to solve the differential equation. Otherwise, instead of doing this differential equation and solving it, it may be taking some time. So I will just tell you the generalized solution of doing this form. Okay, so the generalized solution or generalized form of the solution for the first order circuit is this one. See, Vc of t. If you want to find out the voltage across the capacitance, you apply this equation. You have to find the value of this equation. That is V of infinity. That is voltage across the capacitance at infinity plus V of 0, voltage at the initial value, minus V of infinity into e power minus t divided by tau. Here tau is equal to Rc. So this is Vc of infinity. Write everything as Vc. This is the generalized solution. Okay. Similarly, for IL of t, you can write it as IL of infinity plus IL of 0 minus IL of infinity times of e power minus t by tau. Tau is equal to L by R. Okay. So please remember these two equations. Here onwards, we are working only with respect to, we will work only with respect to these two equations. Okay, now let us see some examples with the RC network. Later in the next video, I will tell you some examples with the RL network. Okay, so this is the first example. In this example, we are interested in finding out what is the voltage across this capacitance and the current I0. Okay. So let us assume the Vc of 0, that is the initial voltage or initial voltage stored in the capacitance given is 15 volts. Okay, initial voltage given is 15 volts. So now what you need to, first thing what you need to understand is, in this given circuit, you are not having any external sources. No DC sources there. So what will happen? The capacitance initially it is at 15 volts. It will try to dissipate energy. It will try to drain all its energy through this resistance, and resistance will dissipate all the energy. Okay. So that is the nature of the RC network without sources. So at a time t is equal to infinity, what will happen? So that is Vc of infinity or steady state. So after some time it will start dissipating. Therefore, after some time what will happen? Vc of infinity time t is equal to infinity. There is no voltage across the capacitance. Initially it was at 15 volts. At a time t is equal to infinity, there is no voltage across the capacitance. So Vc of 0 is 15. Vc of this is given. Now you understood that since there is no external source applied, there is no more charging of the capacitance will take place. Capacitance will only keep on discharging. All the energy will be dissipated as a heat energy in the resistance. So at a time t tends to infinity, what will happen? The capacitance will become 0. It is not having any voltage, any energy stored in this part. Okay. So now you got the values for Vc of 0 and Vc of infinity. You need to always understand the general solution. Vc of t equal to Vc of infinity plus Vc of 0 minus Vc of infinity times of e power minus t by tau. Tau is equal to R into C. Now you got answer for Vc of infinity and Vc of 0. Now you need to understand what is tau. Tau is nothing but R into C. Capacitance is only one value, so you will substitute this value. Whereas R is nothing but what is the total resistance seen by the capacitance, or what is the equivalent resistance seen by the capacitance. So in this network, you check what is the resistance seen by the capacitance. You can see 12 ohms, 6 ohms are in parallel. That combination is in series with 8 ohms. Okay, so you can write that one 12 into 6 divided by 12 plus 6. This plus 8 will give you 12 ohms. Okay, so tau is nothing but 12 ohms into value of the capacitance is 1 by 3. So tau is equal to 4 second. So substitute all these values here. You will get Vc of t is equal to Vc of infinity is 0. Vc of 0 is 50. Vc of infinity is 0. E power minus t by 4. So Vc of t is nothing but 15 e power minus t divided by 4. You got this answer. Now, the question is, what is the value of I0? What is the value of Vc? Whatever is the question, I told you when RC combination is coming into picture, you find only the voltage across the capacitance as a first step. Okay, so that is what we have done. So by now we know what is Vc of t. So we got this answer. Therefore, now to find I0, what you can do, you can see the current I0 which is flowing through the 8 ohm resistance, the same current will flow through the capacitance also. So I0 can be written as C into dVc divided by dt. You know C is nothing but 1 divided by 3. So you have to differentiate the equation which is having Vc, that is 15 e power minus t divided by 4. You have to differentiate this equation. So if you differentiate this equation and do this thing, you will get I0 is equal to minus 1.25 e power minus t divided by 4. Okay, so please don't try to find out the value for I0 initially. Always RC is given. You are finding only the value of voltage across the capacitance. Then from there you can find any other value. Okay, so this is the first example. Consider the second example. In this example, you are having a source. Now what is happening? You can see the switch. There is a switch which is getting opening at a time t equal to 0. So please understand, if the switch is marking like this, it means that it is closing. If the switch is marking like this, you have to carefully watch the arrow mark. It is that it is opening. Okay. So at a time t equal to 0, given is the time t is equal to 0. And sorry, I forgot you one thing. The general equation Vc of t equal to Vc of infinity plus Vc of 0 minus Vc of infinity times of e power minus t minus t naught. It is not minus t only, minus of t minus t naught. Similarly here also t minus t naught. This t naught is the time at which switching takes place. time at which the switching takes place. Here in the first example we don't have any switches or anything, so we are assuming everything is happening at the time t equal to 0. So we substitute in this equation. Okay, so t naught is 0 for us in this example. Whereas in this example again we are having t is equal to 0 only. Okay, so now what you need to see this kind of circuit, what you need to do is initial condition is not given. In the previous circuit what is happening, initial condition is given, Vc of 0 is given. So you are finding only Vc of infinity. Whereas here initial condition is not given, nothing is given. You have to find out what is the voltage across the capacitance. So whenever you are having a circuit which is having the switches, you have to draw what will happen before the switch opens or closes, how the circuit will be, and how the circuit will be after the switch is opening or closing. Okay, so you can see the switch is opening at a time t is equal to 0. So now I will draw two circuit. One is time t lesser than 0, another one is time t greater than 0. So in time t lesser than 0, what is the position of the switch? It is closed. Okay, so the circuit is like this. This is 12 ohm, 4 ohm, 6 ohm, 1 by 6, 24. Okay, and the time t is greater than 0, what is happening? The circuit, the switch is open. Therefore, the source is disconnected from the rest of the circuit point. So your circuit is now like this only. So what do you understand? At a time t is equal to 0, switch is opening. After switch opens, whatever energy, there is no source. Whatever energy stored in the capacitance will be dissipated, and at a time t is equal to 0, the energy becomes 0. T is equal to infinity, the energy becomes 0 for this circuit. Now, you did not know what is the voltage, initial voltage for this one. So that you will find only from this circuit, that is t lesser than 0. We are assuming that the switch is closed for infinity number of time, means that it is in the steady state at t lesser than 0. At t equal to 0 only, it is transient is taking place. Suddenly the changes are coming. So sudden changes are coming, the circuit will become like this. Okay. So during that point only we are finding out how the transient responses, how the steady state responses. Okay. So t lesser than 0, we are assuming the switch is closed for infinite amount of time. Therefore, this voltage, what is appearing across the capacitance, we are interested to find out which will act as a initial voltage to the second circuit. Okay. So whatever you are finding from the first circuit is nothing but Vc of 0, which is the Vc of 0 for the second circuit. Okay. So now to find the Vc of 0, what you need to understand, this circuit is initially at the steady state. Now it is the switch is remaining closed for a infinity amount of time. Therefore, it is again in the steady state condition. Therefore, your simplified circuit will be like this. Capacitance is open circuited under steady state, you know. So whatever is the voltage across this 12 ohm and 4 ohm resistance in parallel is the voltage across the capacitance. Okay, so you have to find out what is the voltage across this point. So what you can do, you can simplify this network. 12 and 4 ohms are in parallel. So if you combine that one, 12 and 4 are in parallel, and then that combination is, since you will get, I think you will get R equivalent equal to, sorry, not for this one. This will give you 3 ohms. So voltage across the 3 ohm resistance. This combination will give you 3 ohms. So voltage across the 3 ohm resistance, I will write it here. So voltage across the 3 ohm resistance for the first circuit is nothing but 24 volts into same branch resistance divided by sum of the resistance. I am applying the voltage division rule. So 24 into 3 divided by 6 plus 3 will give you 8 volts. So this voltage across the 3 ohm resistance is the voltage across the capacitance for this network. Therefore, this is the initial voltage. Vc of 0 is equal to 8 volts. Okay. Now what you need to do, this at a time t equal to 0, exactly what is happening, the switch is opening. There is a sudden change. So sudden change will not apply to the capacitor, circuit with capacitance, as I told you. So it will not respond immediately, but it will slowly respond. So what will happen, the capacitance initially it was having the voltage of 8 volts. Now what will happen, there is no more sources. So capacitance will be decaying and finally all the energy it will get dissipated. Therefore Vc of infinity will be equal to 0. Okay. So now you got the answer for Vc of 0. You got the answer for Vc of infinity. You know capital T, T naught is equal to 0 because at the time T is equal to 0 the switching is taking place. So capital T naught is equal to 0. You need to find the value for tau is equal to R equivalent into C. R equivalent is nothing but for the second circuit only, because at the transient place you got only this circuit, not this circuit. Okay. So at a transient, this is the circuit. So for this circuit, what is the resistance seen by the capacitance? What is it? If it is only one resistance, you can directly take it. But if the circuits involves more than one resistance, then you have to get the equivalent value only. So what is the resistance seen by this capacitance? You can see directly 12 ohms and 4 ohms are in parallel to each other. Therefore R equivalent equal to 3. So tau is equal to 3 into 1 by 6 equal to 1 by 2 seconds, 0.5 seconds. Substitute in the general equation, you will get Vc of t is equal to Vc of infinity, which is 0, plus Vc of 0. Vc of 0 is 8 volts minus Vc of infinity, which is 0, e power minus of t minus capital T naught, which is 0, divided by tau. Tau is 1 by 2 or 0.5. This is the final answer. So you can simplify it and write it as this 8 e power minus 2t. You can write like this. Okay. So see, in this example, what we have seen is whenever you are having a circuit which is having the switches, you are going to draw more than one network. In the sense, what will happen before switching takes place, what will happen after switching takes place. Whatever is the circuit before switching takes place will give you the initial condition, and the after switching will give you the final condition. Okay, so with initial and also R equivalent. So with the final condition R equivalent from the second part and the initial condition in the first part, you can write in the generalized solution. Okay, so this is the next example. Let us consider the third example. So again, as I told you, there is a circuit involving switches. So you need to draw two circuits. One is before switching, another one is after switching. So you can see before switching the switch is closed. So this tells you the switch is opening at a time t is equal to 0. Initially it was closed. So you will have two circuits. One is time t lesser than 0. The circuit is like this. Okay, so this is the first circuit, and at a time t is equal to t is greater than 0, lesser than 0 circuit is like this. Time t is greater than 0, you can see the switch is disconnected, therefore the source is not applied to the capacitance. So your circuit will become simplified like this. So now, as I told you earlier, first you are going to start with the circuit at before time transient takes place. What is happening? You have to assume the switch is closed for a very long time. Therefore, steady state has been reached. So under steady state has been reached, capacitance will act as an open circuit. So if capacitance is open, what is the voltage that will appear across the capacitance is the question mark. So if capacitance is open, what will happen? Your circuit is very simple now. The 4 ohm is of no use now. If the capacitor is steady state of this one. So your circuit is like this. So what is the voltage across the capacitance will act as an initial voltage to the next circuit. So you can see the entire voltage will appear across this open circuit. So VC of 0 is nothing but 9 volts. So this VC of 0 equal to 9 volts will be the initial voltage across this capacitance in the circuit 2. Now you can see in the circuit 2 there is no more energizing sources. So what will happen? As usual, the decaying will take place. So initially it was storing 9 volts as its energy, but as time goes it will be decaying its energy, and slowly, and the time t tends to infinity, all the energy will be decayed and the capacitance will not have any voltage. So VC of infinity will be equal to 0. So VC of 0 is 9 volts, VC of infinity is 0. Substitute in that equation. Therefore, you will be having, before going to the equation, you know tau is equal to R equivalent into C. R equivalent for this is this, what is the equivalent resistance seen by the capacitance. As I told you in the previous example, you are going to find out VC of infinity and tau only for the second circuit, not for the first circuit. Okay. So what is R equivalent? What is it in effective resistance seen by the capacitance? So you can see effective resistance is 4 ohm resistance and 2 ohm resistance are in series. So tau is equal to 6 ohm. R equivalent is 6 into 10 microfarad, which is equal to 60 microseconds. This is the tau value. So substitute in that, you will get VC of t is equal to 0 is the final voltage, VC of infinity is 0 plus VC of 0 is 9 volts minus VC of infinity, which is 0, e power minus t naught. T naught is 0 now because at the time t is equal to 0 switching is taking place. Therefore T naught is 0 divided by tau. Tau is 60 microseconds. Okay. So this can be written as VC of t equal to 9 e power minus 10 raised to 6 t divided by 60. You can even simplify this. Okay. So take the next example. In the next example, you are having 2 point. This is point A. This is point B. At a time t lesser than 0, the circuit is in A position. The switch is in a position A. At a time t is equal to 0, it is switching from position A to position B. So again, you are going to draw two circuit, t lesser than 0 and t greater than 0. So t lesser than 0, your switching is like this. Your circuit is like this. This is 2 microfarad, 70 ohms, 50 ohms. For t greater than 0, your circuit is like this. Very simple. Two microfarad. Okay. So in this case, what you need to do, t lesser than 0 will give you what is VC of 0. Initial voltage, which you can apply here to find the final voltage value. Okay. So initial voltage, as usual, you have to assume before time t is lesser than 0, it is under the steady state. Therefore, capacitance will act as an open circuit. Therefore, entire voltage, supply voltage will be appearing across the capacitance. So this VC of 0 will be equal to 50 volts. Entire voltage will be appearing across this capacitance. Okay. Now t is greater than 0. What will happen? This 50 volts will act as an initial voltage. That is, initially 50 volts is stored in this capacitance. There is no more sources, so the capacitance will dissipate all the energy, which gives you VC of infinity equal to 0, and VC of 0 is 50 volts. You know, you need to find out R equivalent. Here R equivalent, there is no two or more resistance. There is only one single resistance. So R is equal to 80 ohms. So tau is equal to 80 into 2 microfarad is equal to 160 microseconds. Therefore, you can frame the equation directly. VC of t is equal to VC of infinity plus VC of 0, 50 volts, minus VC of infinity, which is 0, e power minus of t minus t naught divided by tau, 160 microsecond. Okay. Now, say for example, if the question is find the current through the capacitance, what you need to do? You are finding only the voltage across the capacitance as the first step. Then you can differentiate that multiple with the capacitance to get to find the current through the capacitance. Okay, so always know whichever is given to you, your idea is to find out only the voltage across the capacitance if the circuit is an RC network. Okay. Now let us consider the another example. This is the next example, number 5. In this example, the circuit, the switch is initially in the position A at a time t lesser than 0 and it goes to position B at time t greater than 0. Now again what you need to do? You need to draw two circuits. So first t lesser than 0, your circuit will be simplified like this. So let me draw this. Parallel, I want you also to draw. So your circuit is like this. Okay. At a time t, 50, this is 50 milli and this is 200, 60 ohms, 10 ohms, 120 volts, 50 volts. This is time t lesser than 0. At a time t greater than 0, what is happening? The switch is coming from position A to position B. Therefore, the capacitance will not have any contact with this one. Therefore, time t greater than 0, your circuit will be simplified like this. 60 ohms, this is 50 ohms, 200 ohms, 50 ohms, 50 millifarad. So you can draw all the values also simultaneously. This is 200, 50, 50 millifarad, 60 ohms and 120 ohms. So as usual what I told you, t greater than 0, this is the circuit. This circuit will give you the initial voltage Vc of 0. So what you need to assume now, before time t is lesser than 0, the switch is in the position A for a very long time. For a very long time, whenever I say that, it means that it is under steady state. So under steady state, what will happen? The capacitance will act as an open circuit. If the capacitance is acting as an open circuit, then voltage across the capacitance is nothing but the voltage across the 50 ohm resistance. You can also see this 50 volts is not having any impact on this capacitive voltage because this is something isolated. Only you are having this 120 volts is connected to this 50 millifarad capacitance. Therefore, this 50 volts is not connected to this 50 millifarad capacitance. So we need not worry about this particular part. So you carefully watch this network. If you are interested in finding out what is the Vc of 0, what is the voltage when t is lesser than 0, that you call it as an under steady state. So that will act as an initial voltage for this respective circuit. So under steady state, this circuit is under steady state, so capacitance will be acting as an open circuit. So voltage which is appearing across the capacitance is nothing but voltage which is appearing across a 50 ohm resistance. So you can see what is the voltage across this 50 ohm resistance is nothing but 120 volts. You apply the voltage division rule. So 120 volts is the total voltage into same branch resistance is 50 ohms divided by sum of the resistance. Another resistance is 10 volts, 10 ohms plus 50 ohms. So this is the voltage which is appearing across the capacitance. So this will give you 100 volts. So this is the 100 volts is the initial voltage to this particular network. Now initially the capacitance is storing the energy is 100 volts. Okay. This is 50, I think, not 150. I should not mistake. This is 50 volts only. Okay, not 120. Sorry. This is 50 because at the time t is equal to 0, switching taking place from A to B. So A to B, this portions will be active. So 50 volts, 60 ohms, 200 ohms, 50 ohms, 50 milli. So this is the circuit, okay, with 50 volts supply. Now in the previous network, what we got answer is Vc of 0 is equal to 100 volts. So 100 volts is initially stored. Now from this circuit, you should find out what is Vc of infinity. That is, at the time t is equal to infinity, what is the voltage appearing across the capacitance. So again you need to understand that it is attaining the steady state at time t equal to infinity. So again you can understand it's nothing but the voltage which is having which is appearing across the 50 ohm resistance or the voltage which is appearing across the 200 ohm resistance. Okay, so you can simplify this. What we can do is this 200 ohm and 50 ohm are in parallel to each other. So what you can do is this 250 are in parallel. So you simplify and write the form. So you get a circuit like this. 250, it will give you the answer is 40 ohms. Okay, so this is 40 ohms. This is the open circuit because under steady state capacitance will be open. So now you are interested in finding out what is the voltage across the capacitance under steady state to get the answer for Vc of infinity, which is nothing but the voltage which is appearing across the 40 ohm resistance. So again I apply only voltage division rule. So total voltage, so you are finding out Vc of infinity now. Total voltage into same branch resistance is 40 ohms divided by sum of the resistance is 60 plus 40 ohms, 100 ohms, which gives you 20 volts. Okay, now you got answer for Vc of infinity, you got answer for Vc of 0. The next step is finding out R equivalent. Now you have to find out what is the equivalent resistance seen by the capacitance. So if you see the capacitance, you make all the source equal to 0. So if you make source 0, voltage source 0 in the sense this will become short circuited. So under this case, under the short circuiting point, you will find this 60 ohm, 200 ohm and this 50 ohm all are in parallel to each other. So, so again otherwise we can also say 60 ohm and 40 ohm are in parallel with each other. So R equivalent is equal to 60 into 40 divided by 60 plus 40, which is equal to 24 volts. You got R equivalent is 24 volts. Therefore, tau is equal to R equivalent into C, which is equals to 24 into 50 millifarad, which is equals to 1.2 seconds. So you got the answer for tau. You got the answer for Vc of infinity. You got the answer for Vc of 0. Now you can find the answer for Vc of t is nothing but Vc of infinity, which is 20 volts, plus Vc of 0, which is 100 volts, minus Vc of infinity, which is 20 volts, into e power minus t minus 0 divided by tau, which is 1 point. This is the answer. Okay. So you can simplify this answer later. This will give you 20 plus 80 times of e power minus t divided by 1.2. So let us see the next example now. Okay, before going into the next example, I should also give you a small introduction about a function called as an unit step function. Sometimes, you know, instead of the switches, you will also be given with unit step function. Okay, so what is that unit step function? As the name implies, it's a step. How the steps looks like? It looks like this. Okay, so at a time t is equal to 0, it is having that stepping. Okay, unit step means that this height is nothing but 1 volts. So mathematically it is written as, expression is u of t. U of t will be mathematically expressed as 1 when t is greater than 0 or 0 when t is lesser than 0. This is the unit step function. And at a time, see, you can see this expression. You are having only values for t greater than 0 and t lesser than 0. You don't have values for t equal to 0. It means that at t equal to 0, this is discontinuous. Okay. So this is the graphical expression for unit step function. And in you have to understand various variant of unit step function also. Say for example, u of minus t. What is u of minus t? U of minus t is the reverse of this. That is, it is 1 when t is lesser than 0 and 0 when t is greater than 0. So it looks like this. That is, from minus infinity to 0, it will take the answer is 1 volts. From 0 to infinity, there is nothing. Okay. And there is also some shifting operation takes place. Shifting operation in the sense, say for example, if it is like this, other than 0. Say for example, it's starting at time t is equal to 4 seconds. What does this mean? This means that there is a right shift. So this will be expressed as u of t minus 4. Okay, it is expressed as u of t minus 4. It means that it is delayed by 4 seconds. So this is given as u of t minus 4 is 1 for t is greater than 4 seconds and 0 for t is lesser than 4 seconds. And you can also have advanced unit step, advancing the like this minus 4. Say for example, so 0 is here only. It has already reached 0 and keep going. So this can be written as u of t plus 4. It's advanced equal to 1 for t is greater than minus 4 and 0 for t is lesser than 4. These are some of the form of the unit step functions. Okay, so generally unit step function is only this one, u of t is equal to 1 for t is greater than 0, 0 for t is less than. Why do I want to tell this point is, see, whenever you are talking about a switch opening or closing, say for example closing at a time t equal to 0, say for example you have a voltage source 10 volts which is applied to the rest of the network. You can also replace this entire combination as like this, 10 times of u of t. What does this mean? This means that at a time t is lesser than 0, this 10 volts will not be applied to the circuit because unit step function will have the value is 0. For time t is lesser than 0, unit step function will have the value is 0. At a time t is greater than 0, this 10 volts will be applied. So instead of the switching, you will also have this unit step function. Under that case, your output is called as a step response. Okay. So the question may be for you is also a step. Let us see some examples, some more examples. So take this example, unit step function is applied here. It means that this 3 volts will be given to this circuit only if t is greater than 0. T is lesser than 0, this 3 volts is not given to the circuit because you are having u of t here. Okay. So again what you need to do, it's something similar to the switching only. So again you have to do two circuit, one is t is lesser than 0, one is t is greater than 0. So you know very well, and t lesser than 0, nothing is there. 1 minute please. So this t lesser than 0, you are having this voltage is not appeared, so voltage is 0. Therefore this place will be short circuited. Your circuit will be simplified like this. This is the circuit which you have at t is lesser than 0. Okay, 2 kilo ohms, 1 kilo ohm, 1 nanofarad. For t is greater than 0, your circuit, the unit step function will be 1. So multiple by 3, so your voltage will appear. So 3 volts, 2 kilo ohm, 1 kilo ohm, and this one. Okay, 1 nanofarad. Okay, therefore now from the circuit what you will find out, you will find out what is Vc of 0. Then you will apply this for this particular circuit. So what is Vc of 0 here? Here you can see there is no voltage source for t is lesser than 0. And therefore, if there is no voltage source under steady state, what will happen? All the energy stored by the capacitance will be dissipated, decayed. So Vc of 0 at steady state will become 0. Okay. Now you have to find out Vc of infinity from this circuit. So Vc of infinity at the time t tends to infinity, that is steady state. Under steady state, the capacitance will act as an open circuit. So if the capacitance acting as an open circuit, what is the voltage appearing across this capacitance? Is nothing but the voltage appearing across this 1 kilo ohm resistance. So you can apply voltage division rule, which is nothing but total voltage into same branch resistance 1 kilo ohm divided by sum of the resistance, that is 2 kilo ohm plus 1 kilo ohm, which gives you the answer is 1 volts. So 1 volts will be stored across this capacitance at a Vc of infinity equal to 1. Therefore now you got answer for Vc of 0, you got answer for Vc of infinity to substitute in the general equation. Now you need to know what is the answer for tau is equal to R equivalent into C. R equivalent is the total effective resistance seen by the capacitance. So for this case, you make the source 0. If the source is 0, the voltage source will become short circuited. So now 2 kilo ohm and 1 kilo ohm are parallel to each other. So under that particular case, R equivalent will be equal to 2 kilo ohm into 1 kilo ohm divided by 2 plus 1 kilo ohm, which is equals to 2 by 3 kilo ohm. 2 by 3 kilo ohm and C is nothing but, so 2 by 3K into 1 nanofarad, which gives you 2 by 3 microseconds. So tau is equals to 2 by 3 microseconds. Therefore, Vc of t is equal to final voltage Vc of infinity plus initial voltage which is 0 minus final voltage which is 1 into e power minus of t minus 0 divided by 2 by 3 times of micro. So you will get Vc of t is equals to 1 minus e power minus t divided by uh, 2 by 3 micro. You can very well simplify this also. Okay. Next example. Take this example. Carefully watch this example. You are having unit step function also. You are having switching also. Okay. So this is an interesting example for you. You are having unit step function also. You are having switching also. Switch is closing at a time t is equal to 0. Whereas unit step function, instead of u of t, now you have u of minus t. I hope you remember what is u of minus t. For time t is lesser than 0, it is 1. For time t is greater than 0, it is 0. So, here also the switching is taking place at time t is equal to 0. So, you are going to draw two circuit. One is t lesser than 0. Another one is t greater than 0. T lesser than 0, what will happen? This source will be present because u of minus t takes the value 1 for t is lesser than 0. So this source will be present, whereas the switch is open. So this particular portion will not be there. So for t lesser than 0, your circuit is like this. (20 volts, 5 ohms, 0.2 farad. Your circuit is very simple like this. For t greater than 0, what will happen? For t greater than 0, this u of minus t is 0. So if this is 0, this is short circuited. This portion is short circuited. This switching is closing. So your circuit now becomes like this. So now again, as usual, what you need to do for the first circuit, you need to find out what is Vc of 0. You have to apply that for the second circuit. Okay. So what is Vc of 0? As usual, what you need to assume, it is there under the state for a very long time. So it attains the steady state condition. The capacitance will act as an open circuit. Under open circuit condition, the voltage across the capacitance is nothing but the entire voltage will appear across the capacitance. So Vc of 0 will be equal to 20 volts. Now, you have to find out Vc of infinity from the second circuit. You got Vc of 0 from the first circuit. Now this 20 volts will be acting as an initial voltage to this capacitance. We need to find out what is the final voltage across the capacitance. So to find the final voltage across the capacitance, again we assume the steady state condition. So again, if you assume steady state condition, your circuit is simplified as 5 ohms, 10 ohms in parallel with 3 ampere source. So you have to find out what is the voltage across this one. So which is nothing but either you can find a voltage across the 5 ohms or you can find the voltage across the 10 ohm, which is nothing but Vc of infinity. Therefore, for this, you first find out what is the current through the 5 ohm resistance. So current through the 5 ohm resistance is apply current division rule. Total current is 3 ampere into other branch resistance, which is 10 ohms, divided by sum of the resistance is 5 plus 10 ohm. So current through this 5 ohm resistance is 2 ampere. So voltage at the 5 ohm resistance, which is nothing but Vc of infinity, can be written as 2 into 5, which is equal to 10 volts. Okay. Now the R equivalent seen by the capacitance. So you make the source equal to 0, current source 0, it's open circuit. So you have only 5 ohms and 10 ohms. 5 ohms and 10 ohms are in parallel to each other because you are seeing the voltage across this point. So 5 ohms and 10 ohms are parallel to each other. So R equivalent is nothing but 5 into 10 divided by 5 plus 10, which gives you 3.33 ohms. So tau is nothing but R equivalent into C, which gives you 0.666 seconds. Therefore, you apply everything in the generalized equation. You get Vc of t equal to 10, which is the final voltage, 10 volts, plus 20, which is the initial voltage, minus final voltage e power minus t divided by 0.666. This is the answer for this particular circuit. The next example, again it's a very interesting example. Here you have to understand two switches are given. One switch is getting opened at a time t equal to 0. Other switch is getting closed at a time t equal to 2 seconds. So far you are seeing only time t equal to 0. Now you got an interesting example at a time t equal to 2 seconds. So the switch is getting opened at a time t equal to 0. The switch is getting closed at a time t equals to 2 seconds. Okay. So for this circuit you will draw three circuit diagram. One is for time t is lesser than 0. Another is for time lies between t is greater than 0 but lesser than 2 seconds. Another is for time t is greater than 2 seconds. Okay, so you will find the final solution for t is greater than 2 seconds only. So what will happen if time t is lesser than 0? At a time t is lesser than 0, the switch is closed position, the switch is open position. Under open position, this 10 ohm resistance will not be there. So your circuit will be simplified as you have this voltage source, 10 ohm resistance, this 10 ohm resistance, this capacitance, this 60 ohm resistance. So your circuit is simplified like this. This is 10 millifarad, 12.5. Simplified like this. Now for this circuit you have to find out the Vc of 0. Okay, so for this circuit you have to find the Vc of 0. Again, what you are going to assume at time t is lesser than 0, it's under the steady state. Under steady state, what will happen? The capacitance will act as an open circuit. If the capacitance acts as an open circuit, the 60 ohm resistance will disappear. Under that case, the voltage appearing across this 10 ohm resistance is the voltage appearing across the capacitance also. So voltage appearing across the 10 ohm resistance, you can see both 2 or 10 ohm resistance. So which the voltage division rule will be equally divided. The total voltage will be equally divided among this resistance and also among this resistance. Therefore, Vc of 0 can be written as 6.25 directly. Okay, so please understand, you are drawing the first circuit for t lesser than 0. Your circuit is like this. For t lies between 0 to 2 ohms. 0 to 2 ohms in the sense greater than 0, not equal to 0. At equal to 0, the switch is open. So greater than 0. After 0, but it is no more, it did not attain 2 seconds. So what will happen? This switch is also open, this switch is also open. Under that case, your circuit is very, very simple, like this. Correct? Under this case, your circuit is like this. 60 ohms, 10 ohms, 10 millifarad. Okay. And finally, at t greater than 2 ohms, what will happen? This switch already is open only. So this particular entire circuit will get disconnected. Whereas this switch will be closed. So this 10 ohm will also come into picture now. So your circuit will be like this. Now how are you going to approach this problem? So initially what you need to do is, okay, now we completed this. Okay, now what we have done, for t lesser than 0 we have drawn the circuit. For t lies between 0 to 2 we have drawn the circuit. For t greater than 0 we have drawn the circuit. Now what you are going to do is Vc of 0, that is at time t equal to 0, is the initial condition for this particular circuit. Okay, and you have to find out what is Vc at 2 seconds, because the circuit will stay only up to 2 seconds. So at 2 seconds, what is Vc of 2, which will act as an initial condition for this particular circuit. And for this particular circuit, you can find out the final condition also. So what you need to understand is the 6.25 volts, which is the acting as an initial which is the steady state condition or final condition for this particular circuit, will act as an initial condition for this circuit, And this circuit, you can see there is no more energizing devices. So all the energy will getting dissipated. So at a time t is equal to 2 seconds, within a fraction of a second, everything will get dissipated. So you will write for this circuit Vc of infinity is equal to 0. Okay, already you know Vc of 0 is 6.25 ohms. Your question is to find out what is Vc of 2. So you, as usual, you have to form the general equation. Then only you will get the answer for Vc of 2. Okay, so Vc of infinity is 0. Vc of 0 is 6.25 ohms. You have to find out the answer for tau, which is equal to R equivalent into C. R equivalent, that is the equivalent resistance seen by this capacitance, 60 ohms and 10 ohms are in series with each other. So total is 70 ohms. 70 ohms with 10 millifarad resistance. Tau will give you 0.7 seconds. Tau is equal to 0.7 seconds. So you apply the general equation. So you get Vc of t equal to, final voltage is 0, initial voltage is 6.25 minus 0 into e power minus t divided by 0.7. This is the answer for Vc of t for t lies between 0 to 2. Okay. So now what is the question? Question is you need to find out what is Vc of 2. So apply t is equal to 2 for this in this equation. Apply t equal to 2 in this equation. You will get Vc of 2 equal to, substitute 2 here. So e power minus 2 by 0.7. If you will get the answer 0.359 volts. Okay, so this 0.359 volts will act as the initial condition for this particular network. Do you understand? So now you have the answer for Vc of 2, which will act as an initial condition for this particular condition. And you have to find out what is Vc of infinity for this. What will be Vc of infinity? As usual, there is no external sources connected. Therefore, all the energy will get dissipated. So Vc of infinity obviously will be equal to 0. So as usual, you have to find out what is the R equivalent. Now R equivalent is nothing but 60 ohms in parallel with 10 ohms plus 10 ohms. These two are in parallel. That combination is in series with this. Okay, so 60 ohms in parallel with 10 ohms plus 10 ohms will give you R equivalent equal to 18.57 ohms. And tau is equal to R equivalent into C, which is equals to 0.186 seconds. Okay, 186 seconds. So substitute all these values to find the final answer. So what is Vc of t? Is nothing but final voltage, which is 0, plus initial voltage 0.359 into e power minus of t minus 2. Here you have to be careful because switching is taking place at a time t is greater than 2 seconds. So you are writing t naught is 2 seconds here. Okay. So t minus 2 divided by 0.186. This is the final answer Vc of t for this particular network. Okay. So again, you can understand at a time. See here you are having two switches. One switch is opening at time t equal to 0. Another switch is closing at time t equal to 2 seconds. So you have to draw three particular network. One is time lesser than 0. Another one is time lies between 0 to 2 seconds. Another one is time greater than 2 seconds. For time lesser than 0, you are having this circuit. This is for time lies between 0 to 2. This is for time lies between greater than 2. Okay. So from this circuit, you are finding only Vc of 0, which is acting as an initial condition for this circuit. And here you have to find the final condition, tau, R equivalent C, and find the tau and substitute in the general equation. Here capital T is nothing but 0 only because switching is taking place at time t is equal to 0. Okay. Whereas, so from this network, you are finding a generalized equation. From the generalized equation, you have to substitute time t equal to 2 to get the initial condition for the next circuit. Okay. So, you have to apply time t equal to 2. You get the answer is 0.359, which will act as an initial condition for this one. So, Vc of 2 is 0.359. Vc of infinity is 0 because every energy will get dissipated. You are finding R equivalent and tau as usual and substituting in the equation. When you are substituting in the equation, here t0 is equals to 2 seconds. It's no more 0. It is 2 seconds. So you are getting the answer is minus of t minus 2 divided by 0.186. Okay. Now let us see the final example of this video lecture. This is the question. You can see at a time t is equal to 4 seconds, no more 0, 4 seconds, switching is taking place from A to B. So now again what you need to draw, you draw two network, one is t lesser than 4, another one is t greater than 4. T lesser than 4 will give you the initial condition, t greater than 4 will give you the final condition and the R equivalent. Okay. So lesser than 4, your circuit is like this. 24, 3 kilo ohms, 5 kilo ohms, 0.5 milli. For t greater than 4, your circuit is like this. .5 milli, 4 kilo ohms, 30 volts. So now what you need to do, again find Vc of 0 by assuming that less than time t lesser than 4, the switch is in position A for a very long time, or capacitance achieved at a steady state, and this becomes open. So if this is open, what is the voltage appearing across this open network? It's nothing but the voltage which is appearing across a 5 kilo ohm. So apply voltage division rule. So what is voltage division rule? 24 total voltage into 5 kilo ohm, same branch resistance, divided by sum of the resistance, 3 kilo ohm plus 8 kilo ohm. So you get the answer is equals to 15 volts. So Vc of 4 equal to 15 volts. It's no more Vc of 0. Please understand it is Vc of 4. From this circuit, find what is Vc of infinity. What is Vc of infinity? At time t tends to infinity, the capacitance achieves a steady state and becomes open. Therefore, the voltage across the open circuit network is nothing but the entire 30 volts. So Vc of infinity is 30 volts. Now, what is tau? Tau is equal to R into C. R is very simple because we are having only one resistance, 4 kilo ohms, and C is 0.5 millifarad. So tau is nothing but 2 seconds. So you substitute everything in the equation. So when you are substituting in the equation, Vc of t is nothing but Vc of infinity, which is 30, plus Vc of 0, which is 15, minus 30 into e power minus of t minus capital T naught. Capital T naught is 4 seconds because switching is taking place at 4 seconds. So you have to write 4 here divided by tau. Tau is nothing but 2 seconds. So this is the final equation. Okay. So now students, I have given you some simple examples and some examples which covers the entire thing with respect to RC. In my next video, I will give you the lecture on RL, similar problems concerned with RL, but the approach will be very similar. Okay. What you need to understand is whenever RC is given, your first target is to find out only the voltage across the capacitance. And from there you can find out current through the capacitance or current through any other thing or voltage across any other thing. Okay. So you can also work out some examples from the Sadiku book and some other books also, or from Google also. You work out some more examples with respect to RC. You can watch my next video to understand the examples with respect to RL. Okay. Thank you so much. Good day.